5-1 today. So you will be having homework due on Monday.
So we will have homework due on Monday?
Yep, your homework's gonna be, no, it's gonna be due on Monday.
Yeah.
So your 5-1 is gonna be due on Monday, so we can finish this up. So you know what to do in that homework. Alright, so according to my notes here, we're ready for number 4 on the back of page 49. And it is exactly what we were doing last time we were together, except, kids, we're now going to be answering in radians. So the problems are done exactly the same way. But our answer, instead of being 60 degrees, will be pi over 3 radians. Okay, that's going to be the only difference. Okay, who remembers from yesterday what we do here? What do we have to do, Robbie?
You subtract tangent over and then factor.
Exactly. I love that. I hope you all were listening to Robbie. He said, subtract the tangent and factor it out. Now, let's talk about that. Everybody make sure you understand what I just did. I did exactly what Robbie told me to do. I subtracted the tangent and then factored it out. Now, some of you, I can't remember if we talked about this yesterday or not, so I apologize if I'm repeating, but some of you may have looked at this and said, hey, let's divide both sides by tangent. No, no, no. Never divide if there is any chance that what you're dividing by is 0. Is the tangent equal to 0 sometimes?
Yeah.
Yes. So because of that, you can't divide by it. So do not divide. Instead, do what Robbie said. Subtract it over and then factor it out. Once you get it factored, then what do we do with these guys? Set equal to 0. Oh, right here. So the tangent is 0 somewhere. And sine squared is 1 somewhere. Now, how do I solve it when it's sine squared? Square root both sides? When you square root them, just like in regular algebra, it's plus or minus. Now, these are zeros and ones. I'm thinking I better look at my circle. So where on the circle is the tangent 0? Now remember, tangent is y over x. So it would be 0 here. Is there any other place it would be 0? Here? So what are these two angles? Remember, we're in radians, so please don't say 180. These two answers are 0 and pi. So the two answers to this one are 0 and pi. I know I'm in radians because that's what this means. That's radians. If I was in degrees, it'd say 360, like we did yesterday. Okay? Now, where, look again at the circle, where is the sign, which is y over r, y, basically y, where is the sign 1 or negative 1? Top or bottom? So the top is pi over 2, and the bottom is 3 pi over 2. Now, this is big time math, kids. We've got to pay attention to lots of things. These answers are actually extraneous. Can anybody tell me why those two answers are extraneous? What? Well, I want you to go back to the original equation. if I plugged in, let's just plug in pi over 2. If I plugged in pi over 2, what is the tangent of pi over 2? What's the tangent of pi over 2? Undefined. Pi over 2 won't work because you can't plug it in the original equation. Anytime the original equation contains a tangent, these angles aren't going to work because you can't have a tangent here. Now, you're never going to have extraneous with sines and cosines because they are always defined. But tangents are problematic, right? So if you got a tangent, throw these out. So the only answer to the problem is right there, 0 and pi. I love the period after one. All right, let's try this one. Tangent squared equals 3. Here we go. How are you going to solve that one? Square root both sides. So if I square root both sides, then tangent equals plus or minus root 3. That might help you if you want to think of that as root 3 over 1. You don't have to, but that might help you. I could draw a picture of this and figure out this angle. But since it's plus or minus, that is positive or negative, what does that tell me about where this angle could be? The positives would be here, negatives would be here, so couldn't I be anywhere? If I'm positive or negative, I'm everywhere. So this is going to have 4 answers. The good news is, all these angles are the same, so I just need to figure it out once. If opposite is root 3 and adjacent is 1, then how big is that angle right there? 60, but remember I'm in radians, so I won't say 60, I'll say, not pi over 6, pi over 3, because remember, pi is 180, and isn't 60 a third of 180? So this is pi over 3. They're all pi over 3. Alright, this is easy. I need you to pay attention. This is easy. Some of you got this already, some of you are still struggling. So, one answer, that blue angle right there, is one answer, and that blue angle is pi over 3. That's the blue angle. Done. The second answer is the red angle.
Pi minus.
Bingo. The red angle is pi minus pi over 3. Here's pi. My hand is pi. Minus pi over 3. So what's pi, a whole pi, minus a third of a pi? 2/3 pi. So 2 pi over 3. That's your red one. Now our orange one goes all the way around to here.
Plus
Pi plus pi over 3, which is 4/3 pi. And then the green one goes all the way around to here. 2 pi minus pi over 3, which is like 2 minus a third, 5/3. And there are your answers to the question. Now, I've made you a little gun shy with extraneous roots. Don't worry about it. I know it's a tangent problem. The only time I have to worry about tangents is when I'm here or here. I'm not there, so I don't need to worry about extraneous. It's all good. All right, let's take a second and have you and your partner, and if you don't have a partner, you can go find one or somewhere over here, see what you can do with problem C. So take a minute and see if you can figure out anything to do with problem C. Remember, you're not allowed to divide. You have to come up with a different strategy.
Oh, that's because it's a multiplier. That's why, sorry.
You're good.
So the sign X then we add one back. And that's where it is.
Yeah. All right, did anybody come up with a plan? Braden, have a plan?
Yeah, subtract the sign.
All right, sounds like a great idea. Subtracted the sine x. And then
Factor out the sign.
factored out the sine x. Perfect. And then, so sine x equals 0, or tangent squared equals 1, which means tangent equals plus or minus 1. Perfect. Everybody get this far? That's great. Now, there's a 0, so you know you're going to be looking at your circle. Where did you figure that the sine was 0? That's y. So here and here. So two answers so far are 0 and pi. Right? Now, this one's a little tricky because you are used to thinking about ones as being on the unit circle, and that's right, except tangent is y over x. And, yeah, so it's opposite over adjacent, so you're not gonna find those here. You're gonna find them out here in a triangle that looks like that, right? How big is the angle in a triangle where opposite over adjacent is 1 and 1?
45.
Radians. Pi over 4, yep, pi over 4.
You have to do all 4 of those too.
Yeah, do all 4 of them. Now, the reason we're doing all 4, I kind of did that fast, is because we had the plus or minus. So that means it can be everywhere, max.
Oh, I just wanted to, I didn't understand the sine x equals 0.
Sine is y,
Right,
so right here, y is 0,
yeah,
and that angle is 0.
okay.
This angle is 90, this angle is 180 or pi, and the sine is also 0 here. Yeah, that's how we got
Both
that.
of them?
Yeah, both of them.
Because the sine's
because y is 0 in both places. So every place y is 0 is gonna be an answer. All right, so here we go, guys. I'm not gonna color code this one, it's the same thing as before. First quadrant, pi over 4. What's the second quadrant angle gonna be? Pi minus pi over 4, which is 3 pi over 4. You don't need to write this out. I am, to help those of you that still need a little push there, but it's 3 pi over 4. What's the third quadrant angle? Pi plus 1/4, so that's gonna be 5/4. And then the fourth quadrant angle is 2 pi minus pi over 4, or 7 pi over 4. So this problem actually has 6 answers, right? 4 coming from there and 2 coming from here. All right,
And
Jake?
so one time when you'll worry about the extraneous solutions is when it's equal to tan.
When you have a tangent and the angles are these. Because this is where tangent is undefined.
Okay, but if it was like cos and it was those two angles, it wouldn't matter.
Cosine, no.
Yeah, okay.
All right, everybody okay with that problem? All right, how about, oh, Max?
Why did you use 2 pi on the left?
Because I'm looking for this angle right here,
And that's 2
which
pi.
is all the way around except for this last little bit. So all the way around is 2 pi. But I didn't make it quite all the way around. I made 2 pi minus a 4.
Before you did pi minus and then pi plus.
Because I was operating from this line. Right? All right, anybody notice anything about that guy? He looks big and scary, but he's actually quite easy. You can factor it. Sydney says this thing is a quadratic equation. Any idea, Sydney, how to factor it? Oh, come on now. We know this is gonna have to be -1, -1. Would you agree with that? 2 cosine? Will that work?
Yeah.
So I see what Robbie's doing. Robbie, you're on fire today. Thank you so much. He's up here going like this. So what's he doing? He's checking my factors by foiling them together, because that's how you check to see if you're right. So what's it say? Cosine equals 1/2. They both say the same thing. Set it equal to 0. So cosine equals 1/2. You don't have to solve it twice. They both say the same thing. Where does cosine equal 1/2? Now, there's no plus or minus, so pay attention. Where does the cosine equal 1/2? Quadrant 1 and
3.
oh my
4.
gosh!
It was 4. 1, 2.
Cosine is x. Where is x positive?
4.
Quadrant 1 and 4. People are stressing me out.
I just didn't want to say it.
All right, so how big's the angle?
60 degrees, pi over 3.
Pi over 3, very good. I like the way that your thought process there, pi over 3. So, only got 2 answers. What are my 2 answers? Well, one of them is pi over 3, right? Quadrant 1 is quadrant 1. What's the quadrant 4 angle? 2 pi minus pi over 3, which is 2 minus a third, so 5/3. All right, you good with that? Okay, notice that all these equations, I have not needed a calculator. And the reason I didn't need a calculator is because every one of my angles came out special. Okay, So the only difference now is, this next one here, number 5, we are going to solve, but the angle isn't special. Do you recognize that? 0.37 is not one that I have memorized, like
Yeah,
root 3 over
me
2. So, the setup, I'm gonna need my calculator, but the setup is the same. If the cosine is 0.37, where is the angle? Where is it?
1.
It's in quadrant 1 or,
3.
oh my gosh, are you doing that on purpose?
Definitely not.
Oh my gosh, we just talked about it. Cosine is
Miss
x.
Ford, I like
I
to see you go
said
crazy.
flow.
I know, I already have so much gray hair, do not do this to me. Alright, so cosine is x. X is positive
1 and 4.
in 1 and 4. Now, I have no idea what this angle is, but I'm going to find it on my calculator by pressing what buttons? Second cosine, 0.37. Now, depending on how you're set up, kids, you got maybe 68.3. Anybody get 68.3? But some of you may have gotten something else. Because if you're in radians, second cosine 0.37, you get 1.19 or 1.2.
Wait.
Press the same buttons. It just depends whether you want your answer to come out in degrees or whether you want your answer to come out in radians. Since the question says do both, I've done both. So, one answer in degrees is 68.3. What will be the other answer in degrees? 360 minus 68.3 or 291.7. Does that make sense to everybody? Now, one answer in radians is 1.2. What will be the other answer in radians? 2 pi minus 1.2. So we're just doing on the calculator exactly what we've been doing by hand. 5.08 or 5.1. If I run in there's 10. Done. Easy peasy. All right, now what about number 6? The tangent is 5. Before you go to the calculator, tell me where these answers are going to be. Quadrant 1 for sure. And 3. Because isn't opposite over adjacent positive down here? Okay, so now I'll go to my calculator, and second tangent 5. I'm in radians, so on my first pass I'm getting 1.4. Now I'll do the same thing in degrees. Second tangent 5. I got 78.7. Now,
What is that, 78.7?
that's what I got, 78.69. All right, so now I gotta find all my answers. So back to radians here. One answer was 1.14. What will be the second answer? 1.4 plus, I'm in radians, plus pi. 4.5. And then down here in degrees, one answer was 78.7. The other answer will be plus 180. 258.7? Everybody okay with that? All right, I need to make one more comment though. Because there is a word in the directions that bothers me a little bit. That word all. So I want you to stop and think for a second. Let's just look at the one we just finished. 78.7, for example. 258.7. Those two angles have a tangent of 5. There's no question about that. Are there any other angles that have a tangent of 5? How about, I'm going to, how about 438.7? What's 438.7 look like?
78.
It's all the way around 360, so it looks like this. If I drew it, it would look like that. Does that angle also have a tangent of 5? Yeah. How many angles are there that have a tangent of 5? Infinitely many. So it starts with these two. These are the beginning. But then, how do I get all those other infinitely many ones? I add or subtract revolutions. Remember when you found coterminal angles?
Yeah.
Yeah. So what we do is, we take these two right here, and we add or subtract, because you can add revolutions or subtract revolutions, multiples of 360. So we add 1 360, 2 360s, 3 360s, and so on.
Is that just for 5?
No, this is how you name all the angles. You have to find your main ones, and then add or subtract revolutions.
So on like the one before that, is there the same thing happening?
Here, we're gonna add or subtract 2 pi's.
Okay.
Because we're in radians. That N stands for the number of revolutions. So you can add 1 extra 2 pi, or 2, or 3, or 4. And likewise here, these answers. So this one would be these plus or minus 2 pi n. And it would be these plus or minus 360 n. So if we're in degrees, we're adding 360s. If we're in radians, we're adding or subtracting 2 pi's. Okay, got it? Now, the only reason I did that is because it said find all. And there are infinitely many of them. Okay? All right, that's it for that section. So your homework's due on Monday. We already talked about that. So now we're going on to section 5.2, which I know it's the period after lunch. I know it's the end of the day before a longer weekend, but I really need you to pay attention, and I need you to keep an open mind, because what we're about to do can get a little bit wild and wacky. Does anybody have any idea what the word verify means? Prove. Yeah. So what we're getting ready to do is a trigonometric proof. Just like you did proofs in geometry. It's structured a little bit different, but it is a proof. We are doing a proof. So here's our job. Our job is to mess around with this and change it into that. So remember how in geometry you had the given and you had the 2 proof, and you started with the given and ultimately, hopefully, you ended up with the 2 proof? This is your given, this is your 2 proof. So I'm gonna see what I can do with this to end up with that. This is an easy one. Get out your reference sheet and tell me about sine squared plus cosine squared.
Equals 1.
It's 1. So what I have now, so the first step of my proof is gonna be 1 over cosecant. That's the first step of my proof.
That equals sin X.
And the reciprocal of the cosecant is the sine. So you're done, kids, you did it. You just did a proof. How easy was that?
I'm not gonna stay that way. Just making suspicion.
All right, next. Again, we're keeping an open mind. We are not freaking out. I do have a little suggestion for you. There are a whole lot of problems like this, but sometimes it's easier to rethink this as literally tangent divided by secant. Isn't that what this means? Tangent divided by secant? And sometimes that's helpful because tangent can be rewritten as a fraction. What's tangent? Sine over cosine. And we all know that secant is 1 over cosine. And when I have it written this way, then I think back to my Algebra 1 days, or even before that, where we had to divide fractions. Remember the old keep, change, flip thing? So we'll keep this. We'll change the division to a times and flip that. Well, what happens? Those cancel, and what am I left with? Which is exactly what I wanted.
Let's go.
I know. Isn't this fun?
No.
Yeah.
It's easy.
All right, let's look at the next one. Again, we're keeping an open mind. We're not going to be frightened.
Scary.
All right, so tell me what you might do. There's lots of ways to start, just like in geometry, lots of ways to start. What might you do over here?
I'm thinking.
Well, I see this parentheses, and what do I automatically think about doing? Distributing. Now, is that wrong? No. It's perfectly legit. I'm going to distribute. So cosine times tangent plus cosine times sine times cotangent. Now look at, this is your to prove right here. Are there any tangents in that? In the to prove, are there any tangents? No. So let's get rid of this tangent. What do I know about tangent?
It's sine.
So cosine times sine over cosine. And then what about cotangent? Let's go ahead and change that one too. That's cosine over sine. Now don't you dare say, but that's not on my sheet. It doesn't need to be on your sheet. It's the reciprocal of the tangent. All right, you notice anything? These are gonna cancel, aren't they? Remember, that's cosine over 1. This is all over 1. So those cancel and leave me with sine. What happens here? Those cancel and leave me with,
Cosine squared.
oh my gosh. You gotta admit, that makes you happy.
No.
I don't think you're picking up.
We bring everything over.
Oh, we did it.
We don't bring anything over from the other side.
Is it?
We don't ever. This side stays the same. So that just actually, I ended up
Oh,
changing
yeah,
it into that.
gotcha.
All right, a few more here. Tangent plus secant equals cosine over 1 minus sine. We are on our fourth problem, so you're not like experts on this, but I'd like you to just think about what might be a logical thing to do.
And secant.
Change these guys into
Yeah.
what they are, sines and cosines,
Like the same, oh, it's forward.
right? Doesn't that make sense? So what's tangent? Sine over cosine. And what's secant? Now, normally at this point, I would be saying, hey, let's get a common denominator, but I already have one, right? So now I have sine plus 1 over cosine. Oh, boy. That is not what I'm supposed to end up with, is it?
Oh, I forget it.
So for the first time now, we're gonna have to do something a little bit tricky,
Jig.
okay? A little bit tricky.
Couple of things in there.
Okay, I want you to remember, this is my two proofs. I want to somehow end up with a cosine in my numerator. So here's what I'm going to do. I'm going to put a cosine in my numerator. Now, that is completely legit as long as I also put one in the denominator. So I know now you're thinking, well, Mrs. Ford, now it looks even worse. Focus in, focus in. I know this is exciting and fun. But I have cosine, sine plus 1 over cosine squared. Now, please don't cancel, because while you can, that's just going to take you right back to where you were. So instead, I want you to think about cosine squared. What do I know about cosine squared?
You add sine squared.
Okay, so now I can't do that though. But what I can do is, suppose I move this over to this side of the equation. So what does cosine squared equal?
Minus sine.
1 minus sine squared? So I'm going to change that denominator into 1 minus sine squared. One minus sine squared is factorable. It's the difference of squares. So the denominator is going to factor as 1 minus sine, 1 plus sine. The numerator is already factored. And what do you notice though? These guys are going to cancel. And what am I going to be left with? What I wanted, which is cosine over 1 minus sine. Okay? So we started with a couple really easy problems. That was a little bit trickier, but let's kind of keep a mental list. What did I do? What new trick did I introduce there? If you want something, you can put it in, as long as you're multiplying the top and the bottom. Right? You can always do that. That's always okay, as long as you're doing it to the top and the bottom. Okay, a couple more. Here we go. Practice makes us better, guys, so we're gonna have to practice these. But think about, here's my given, that's what I wanna end up with. So what might be a good thing to do?
Well, secant x is a reciprocal of our cosine. So we'll probably use that at some point, right?
I think we're definitely gonna use that at some point. And we can use that right off the bat if we want, but I also want it, along the same lines as over here, what do I know about tangent squared? Look at your thing. Well, I know it's sine squared over cosine squared, but what else is it? What else is it? Look on your paper. Doesn't your paper say 1 plus tangent squared is secant squared? Right? Are you seeing it?
Yeah.
So if I move this 1 over here, what does tangent squared equal? Secant squared minus 1, which is, guys, the difference of squares. So that's secant plus 1, secant minus 1. So what's going to happen? So now I'm at the point where I have secant x minus 1. So Jake, now I'm absolutely going to follow your advice. I have secant minus 1, but secant is 1 over cosine.
Yeah.
Let's get a common denominator. What's our common denominator? We have 1 over cosine and 1 over 1. So I'm gonna multiply this one by cosine. Don't I have it? 1 minus cosine all over cosine.
Multiply that, okay.
Multiply top and bottom by cosine to get the
Yeah.
common denominator.
Yeah.
Denominators match, so I add the or subtract the numerators. Now, both of the last two problems, we have done something, some rearranging with these, what are called the Pythagorean identities, right? For both problems, we did something like that for watching a clock. And then, once we've done that, we factored and canceled. All right, I promise I'm gonna stop after one more problem, okay? One more problem. Number 6. Stay on track here, guys. Everybody's on track. All right. Here we go. He's got a plan. Here's my given. I'll do something.
Sign,
What, Amanda?
you still need it, so never mind.
You were gonna do something with the
Yeah.
sign?
Yeah, but I was gonna cancel them.
Oh, how about this? I got
Okay, now, first of all, they aren't gonna cancel because that's a plus,
Oh,
right?
Uh,
That's a plus.
wait. Yeah, so if we just find a common
Yeah, we got a fraction plus a fraction. Not this,
Oh,
this
yeah,
is the
no,
two
you-
proofs.
yeah.
But these two have to be added. So my common denominator is gonna be 1 minus cosine and sine. Both pieces are my common denominator. Okay? So this one already has that piece. So this one's gonna have to be times by sine,
Yep. Sine squared.
making sine squared. Plus, all right, now this one is gonna have to be multiplied by
1 minus.
1 minus cosine. So the denominators are the same, so that's why I can write it as one fraction. And this is 1 plus cosine times 1 minus cosine. Okay, so I put a sign in the first one, and I put a 1 minus cosine in the second one. Okay, what do you suggest now?
Cancel.
Nothing cancels, got a big old fat plus sign right there. Nothing cancels. Nothing cancels. So what am I, it's like, it might be easier for you to see, if you had x plus y over x, can you cancel the x's? No. Okay. So what's your thought there?
Well,
I'm gonna leave the bottom alone, but I'm gonna FOIL that out.
I was thinking about that.
So I have sine squared plus, now I'm gonna FOIL these. Now, 1 minus cosine is not sine. That identity is squared. They gotta be squared. So I can't use any identities at this point, but I can FOIL that, like regular math, FOIL. So what do I get when I regular FOIL?
You get 1.
I get 1
Yep.
minus cosine plus cosine minus cosine squared.
Now I have a question. If it's like,
The cosines cancel each other out.
so the sine squared plus cosine squared is equal to 1. If it was like sine minus cosine, is that equal to -1 or no?
No, I see what you're saying, no.
Okay.
But what's this? Oh, wait a second. I don't wanna do that. How can I rewrite sine squared? What does sine squared equal?
1 minus cosine squared.
Okay, what if I did that? What if I changed this right here into 1 minus cosine squared? Now, you're going with me, you're not freaking out, you're going with me for a second. Because I noticed that in my answer, my to prove, it's all cosines on top. So I said, let's get rid of this sign, we can do it. All right, what do we have now on the top? Can that be simplified at all? Into what? Isn't it 2 minus 2 cosine squared? Guys, you gotta stay with me. The minute you start talking and screwing around, you're gonna be lost. Collected like terms, 1 and 1 makes 2, negative and negative makes -2. Can I do anything to the top of that? Take out a 2. And can I do anything with 1 minus cosine squared? Well, that equals sine squared, but I don't want to go there because I want to end up with this. Doesn't that factor?
Yes.
Okay, just like in geometry. Keep an eye on your G proof. That's the end goal. That's where I want to end up. So I don't want signs on the top. I'm going to go ahead and factor this right here. I'm factoring that. 1 minus cosine, 1 plus cosine. And now what happens? After I factor, I am allowed to cancel. And 2, 1 plus cosine over sine is what's left. All right, we just finished 5.2. So you're gonna have 2 assignments, but I'm gonna give you an extra day.
Oh,
They're
that's
gonna be due
all.
on Tuesday, all right? So both assignments due on Tuesday. So if you wanna get one done and turned in earlier, that's fine. Both of them are due on Tuesday. Please spend a little time on this, guys.